Everyone, I am MD Jahidul Islam, a PhD candidate at UMass Lowell. I will present sensor network routing for resilient observability of power grids. Power grid is a complex system as shown in the figure. The horizontal lines are the buses that represent electric poles or substations. A special sensor for power grid is phasor measurement units, which measure voltage and current phasors and many other grid-related parameters. PMU are placed on different bus locations. Each PMU measures voltage phasor of its own bus and the neighboring bus. So we need a minimum number of PMUs to obtain voltage phasors of all the buses, which is known as grid observability. In communication network, routers forward data from one router to another via the communication links. The routing means finding data forwarding path from source to the destination, which is the control center in the figure. Routing algorithm help us in this regard. Ensuring power grid observability facilitates many applications, such as enabling secure and reliable operation of power system and identifying faults and taking preventive actions. However, there are some challenges as well. We need to consider the properties of two complex systems, that is power grid and communication network, and we should maintain observability against failures, which is known as resilient observability. So the objective of our paper is to achieve resilient grid observability, and for this purpose we will propose a routing algorithm to find the routes in the network from sensors to the destinations. Here I will explain the proposed method with an example. In power grid, we place PMUs in the same group if they observe a same bus, and they are named as shared observability PMU groups. As shown in figure, PMU at bus 7 and bus 9 creates a SOPG as they both observe bus 8. So all the possible SOPGs are shown in the figure. In a communication network, we initialize tree from the adjacent links of the destination. If we expand the links, three linked disjoint trees are formed as represented by three different colors in the figure. In the process, we can connect the PMUs to the trees. To ensure resilient observability, the criteria is that all the PMUs of a group do not join the same tree. As shown in figure, PMUs 3 and PMU 9 join two different trees. At the end, following the same process, we get the final routing configuration as shown in the figure. As novelty, I want to highlight that this is the first research article to include power grid observability concept into network routing algorithm. Compare the proposed method with a baseline from literature on IEEE 57 bus test power system. Figure 1 shows that our proposed method achieves 100% observability with lower delay than the baseline, enabling real-time decision-making capability. Additionally, table 1 demonstrates that our proposed method uses 50% less resources than the baseline, resulting in lower cost. In our future work, we aim to develop a generalized framework that considers more properties from power grid and communication network, and that will ensure observability against multiple failures. Thank you for your attention.